All right. All right. We're up and running. Let's just wait a couple of minutes before we start, okay, Einar?
Sounds good. Take your time. You hear me?
Yep, very
Perfect.
well. I'm gonna introduce you, Einar, and
Sounds good.
afterwards I'm gonna give you access for you to share anything you would like to share from your computer, okay?
Sounds good. Yeah.
Yeah, just wait before. Let me just introduce you. Just wait 1 more minute, and then I just share you the screen, okay? So you can have access because I think you don't have access right now.
That's fine. I'm closing out some of my pages right now just so it's more clean.
Okay. All right. Okay, guys, let's just start the conference. I would like to introduce Mr. Einar Terrill. He's an aerospace engineer who recently presented his final project from the college degree to the NASA, and it was very interesting because they made very good and great comments about it. He's 20 years old. He's graduated from the University of Maryland in College Park, and he's right now pursuing to follow a career in satellite attitude control and propulsion systems. And it's very interesting because now that what happened with SpaceX these last few days is very interesting because this is actually our new frontier. It's not only frontier inside the air, but it's we are just ready to start sending people abroad to the space station, maybe later on to the moon, and maybe a bit more in few years, and probably 5 to 10 years to other planets such as Mars, for instance. So, Einar, just go ahead and tell us anything you like about this great topic. All right.
Absolutely. All right. So really everything about the aerospace engineering field, and in specific, just space exploration, what I truly like about it, it's so entirely technical that all the problem solving behind it is so satisfying when you get down to it. When you've solved that problem and you get to that final answer and you know that that answer is the answer, there's no like beating around the bush. There's no, well, there's this main point here that we need to beat around. No. It's just a number. And that's what engineering is done through. It's done with numbers. And I've always loved just doing math and being able to apply math to the real world and using it as what it really is. The language of our universe is a lot of fun and it's really satisfying. And I love being able to just pursue this new frontier as Eric put it, in really our pursuit of science. We've got a space force here in the US, for better or for worse, but it does promote further space exploration, further space research. And we just launched the Falcon 9 into space the other day with astronauts on board towards the International Space Station. So we are furthering our exploration as the days go on. And I actually put together a presentation here on Keynote, if I can gain access. There it is. And this is just kind of a rundown of what goes on when you're trying to just when going through the studies in my case, at University of Maryland. And it really just starts out where you cover on all the technical things that are required in pursuit of space and, well, just engineering in general. There's a lot of trigonometry, there's a lot of calculus, a lot of geometry, there's a fair bit of chemistry and a lot of physics. And you're gonna be forcing it into your head all throughout your time in studying this. So if you really don't enjoy that, you probably won't enjoy it. It's very frustrating at times, and a lot of it is gritting your teeth and getting through it. And I've always been the kind of person that just liked to do physics problems for fun. As I put there, physics does equal fun. But it was really frustrating at times, and it was hard to get through it. And sometimes it did feel easy to quit, but you can't. And if you really aren't good at math, or you don't think you are, give it a shot anyway. Maybe you are. I wasn't good at math early on in my high school career. So I only discovered that I liked it when it became fun, and when I started realizing that you can use it in the real world. And then when you get down to your later years in studying aerospace engineering, you get down to the grittier, more applied parts of this technical study, like the aerodynamics, how fluid flows around an airfoil or a rocket as it takes off through the atmosphere. Orbital mechanics, how things move in a vacuum when there's a massive gravitational body keeping it bound on this elliptical orbit, or not even that, when it has enough energy to just fly by the planet, and you're able to utilize that planet's energy to propel your spacecraft further. Cool things like that you study in this field, and you actually figure out how it all works physically. And it's very interesting. And then a personal favorite of mine is control theory, which is really taking the language of the universe and manipulating it through machines, through sensors, and using feedback data to constantly update your current situation and, well, actuate forces into the system to return things back to an equilibrium state. Anything like that. It's all really cool, and it is stuff you study when pursuing a field like this. And when it all comes together, you get something like this, which is a support structure that I presented to NASA, which is actually built around the idea of a barrel structure that you find in a brewery, because our horizontal habitat on the planetary environment was cylindrical and horizontally oriented. So this sort of design worked beautifully in this kind of application. As you can see on your right, it deflected very minimally, and that is all very much, over dramatized in that picture. It didn't deflect nearly that much. And this is what in particular NASA really liked, which is what I called my dumb ladder, which is really a ladder dumbwaiter hybrid that allows astronauts to ascend multiple floors on a habitat and also ratchet their cargo up to the multiple floors after they climb. And what's great about this is that it's very safe and it's very simple. And what NASA especially liked was that they would be able to incorporate this into a wide variety of habitats, which in particular, they were pursuing a mission to Mars, and they wanted to incorporate this design in their mission to Mars, which was very flattering and it got me really excited to pursue this field. So that's really all I have for my presentation. But in the end, it's just a very satisfying and very fun field of study. And if you have any interest in it, I would very much recommend you pursue it. And if there's anything else.
Einar, I have few questions about it. Can you, I mean, there are many students, mid-schoolers, high schoolers in the conference. And I would like to ask you, what would you suggest them? I mean, they have ideas, they have great ideas. They are just currently participating in a business competition. So what would you suggest them for getting into this field? Or because probably they don't realize that they can have ideas, they have innovative ideas, and they can propose to organizations such as NASA. Tell about your experience and tell what you recommend them.
Well, there are plenty of simulation programs out there on the internet. I can't remember off the top of my head, but there's actually a game on Steam where you can simulate a launch environment. I don't remember the name. I really should have looked it up prior to this, but it's a lot of fun and it's very popular. And something like that, you can continuously test different rocket designs, you can test different launch environments and see what works. And if you've got a certain idea of maybe a revolutionary launch vehicle design, or like rockets are all shaped the same, maybe rockets aren't the shape we need, maybe it's a different shape. And if you've got an idea like that, that's the kind of program that we can simulate environments like that and really try to propel our research forward. I can't really hear you.
Okay. So, okay, thank you. And for instance, have you checked how many projects from your age or even younger age have been shown to NASA guys?
Every year there are so many. At my school and many universities across the country, I'm not sure about for the younger ages, but they hold this competition every year for the sole reason of using eager young minds with the rich amount of ideas that they have, and really, for lack of a better word, stealing them from them while they're pursuing their education, because then the students get a degree, which they want, and NASA gets ideas. So it really happens every year, and it's very interesting to see over the years the awesome ideas my peers have had. Like for instance, one group managed to simulate an entirely waterproof environment because they gained access to a piece of a large PVC storage container that someone drove a forklift through by accident on a farm. And since we paid for shipping, they were able to transport it over, and then they used that to simulate an entirely vacuum and a full vacuum environment. It was awesome.
Great. There's a question from the audience. Is how can young students make technological startups, in your opinion, and what is the biggest challenge you have had developing these kind of technologies?
Learning the programming languages, just learning how to use the really complicated software. If I had to recommend anything, get yourself immersed in it early. If you don't know, if you play around with programming now, like C++, Python, even MATLAB, do it. Like, please keep doing it, because it is so important in the technical world to know things like that. And that is all the stuff I was using in my field. Like for one project we had to drive a remote like a car that was pre-programmed through a maze, and we used Python to program that in. So if you play around with Python now, keep it up. And it's really not that difficult to learn. And I really wish I learned it at an earlier age. So, and that's all startups are based around a lot of times. There's always at least one technical guy that is the one who knows how to do code. And if you know code, then you're off to a good start.
Have you seen projects like from university or even younger, just being sold to space companies such as SpaceX or others, and or ideas or innovations. Can you expand a little bit more on this?
I have to think. I haven't personally witnessed anything being sold. I haven't heard any news, like specific news from any of my professors about that, but I'm pretty sure that they don't, like when you're a student, you kind of sign away any idea you have. You really can't sell it. So the school kind of takes responsibility, like takes ownership in whatever you make. So I guess that's really why I haven't seen that happen. But as far as the great minds created in like the programs I've been in, yeah, there's a plethora. And like NASA Goddard is right down the street. I'm pretty sure half of NASA Goddard is staffed by University of Maryland aerospace engineering students. So
Is space technology something accessible for anyone?
depends on what you mean. Not really. Like the actual like hardware is, we're talking like millions of dollars. But when you talk about like the software, maybe designing the control systems, designing a landing sequence, something like that, you can kind of do that through simulations. But that's the closest I can think about. These are massive structures, and like these projects to create these rockets are in the billions of dollars. So that's the biggest issue in sort of trying to design some of these things yourself. It is so expensive.
Okay, one question. What I mean, can you mentioned that you made this ladder, right? And what the NASA guys told you about it?
I designed the ladder in a program, so it wasn't actually made in particular. They saw a slide that kind of looked like this, and what they said is they liked that it was man powered, like there's a pulley on top. So there is no external power system that is required to power the carrying the loads up. And currently the only way that people have to really carry cargo up to another level on a planetary habitat is to carry it up some stairs. And that isn't very safe. But if in this case, you can just kind of set it down the platform, climb up the ladder, and then ratchet it up later, and there's really no risk of you falling off or damaging the cargo. So that's really what they liked about it. They could see it being used in a variety of situations.
Okay. We have seen Chinese guys sending a crew to the International Space Stations and to the space. We have seen Russians, even Europeans. What do you think? I mean, how US is doing in technology uh, compared to other people
We're
around the
doing,
world?
we're doing great. I think the biggest reason why we've been so apprehensive about sending people into space is that we just don't want to kill people. And that's just the biggest. It's a big political thing. It's not about we don't have the technology to do so. We definitely have the technology to do so, and I assure you of that. And I'm pretty sure we're probably the furthest along, if I were to guess, as far as knowing how all the other countries are. But there's a massive space industry across the world. So I may be totally wrong. Maybe there's another country that is secretly has already talked to aliens. Who knows? But all I know is that the U.S. has all the resources it needs to do like the pinnacle of space exploration. We just don't want to kill people because there's a lot of risk that goes into sending somebody into space. If you miss completely, you might end up lost in space, and that's terrible. If you are off, not even on a bound orbit around any sort of gravitational object, you're going to drift off indefinitely, which you're dead pretty much at that point, and that's like that's billions of dollars also drifting off into space, and you don't want that.
Elon Musk was telling that in not more than 10 years, they will be sending people to Mars. Do you think this is going to happen? And what are the main constraints about it?
I think we could right now. The main constraints are, well, the sand on Mars is terrible. You can't, it will damage, it burns the skin. Also, there's no air over there. The atmosphere is toxic. It's got an atmosphere, so if you land, you can burn up in it. There's a lot of challenges, and all these challenges tied together, again, kind of goes back to what I said earlier about it being political, and we don't want to kill people. And I don't think Ridley Scott did us any favors in making The Martian and showing what could happen in that situation. I mean, it was pretty awesome, but my favorite movie, but it's not things like that could happen theoretically. And if something goes terribly wrong, we would be set back for years and years and years and years. Like, we're talking probably about 50 years setback if like we sent about 5 people to Mars and they all died. So that, I think that is our biggest problem. But yeah, within 10 years, I definitely think we can make it to Mars. Hell, I think we could do it earlier than that.
Okay, earlier you mean 5 years or?
Yeah, I think we can do it now, but it's just a matter of the politics behind it, killing people.
Wow. Okay. Okay. If there is any question from the audience, just let us know. There is a question saying if there are aliens over there.
I can't hear you. Oh.
Yeah, if there are aliens, and think that is there some intelligence outside there? What have you heard about it, Einar?
Oh, I haven't heard anything. I was just kind of making a joke there, but yeah, honestly, in my studies, I'm actually kind of happy to have said we didn't talk about aliens once. I didn't even have a corny professor bring it up. So it's a pretty serious field.
Okay, cool. Cool. Okay, so is there any other question from the audience? I think it's a pretty interesting topic. And I think there are many young kids, many guys that are willing to get into that field. Probably they fear about physics, maths, and all these kind of things. But you know, it's part of it. I mean, if you want to do something or achieve something and be part of the new generation of doing great things, great innovations, space innovations, for instance, you need to start digging on a little bit, right?
Absolutely.
So yeah, as you mentioned, probably learning about these simulators that are probably free there. I was once in a program where I allow my computer to use the processor to search for certain information on space and things like that. So I mean, you can start doing things. I used last time a satellite following software where basically you only add a file with the telematics of it, and it's not very hard to see what satellite is over you at that time and that precise time. So or so some other radio RC guys that are just calling the astronauts by on a standard radio, right? So yeah, I mean, there are many things we can do. There are many. It's only matters of just willing to get into that field and just start playing as Einar did.
Yep.
Yeah. So
work, but it's worth it.
Yeah. So if you want to add a comment or any recommendation to the guys that are in the audience, feel free.
Work hard and keep it up. Great questions.
Okay. Okay. Well, Einar, thank you very much for your keynote. It was very interesting talking about the space and all these innovations that you just shown to these NASA guys. And especially because of all this, what is happening last few days on the SpaceX stuff and sending some crew to the International Airspace Station. So let's see how things moves, and I hope you do very well with all these kind of projects. Okay, Einar?
Thank you so much. Thank you for having me.
Okay. Okay,
Take it
guys.
easy.
So next conference will start in around half an hour. So thank you very much for attending this keynote, and we just keep on moving. Okay. Thank you. Bye bye.